Okay, hello everyone. I welcomes to all in our lecture series on mathematical physics, that is your core paper 8, belongs to 4th semester BSc Physics on our syllabus CBCS model. This is your lecture number 3. In our last lecture we have been discussed Euler's formula, and also we have been discussed polar form of complex number, principle of argument and principle of argument, and few numericals based upon principle of argument and argument. In this class, we are going to discuss Demoivre's theorem and corresponding numericals. Okay, so let's start. So this is the statement of Demoivre's theorem, that according to Demoivre's theorem, cos theta plus I sin theta to the power n will be equal to cos n theta plus I sin n theta. This we are going to prove by considering n will be positive integer, that is your case 1, and we are going to prove by considering n is your negative integer, and also if n will be fraction also, that one we are going to prove also. Demoivre's theorem also we are going to prove. So first we are going to consider case 1 when n is the positive integer. Consider multiplication of two complex numbers. Here cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2. Just multiply it. Here you can see cos theta 1 into cos theta 2, cos theta 1 into I sin theta 2. Here I sin cos theta 1 into sin theta 2. This term into this term, I sin theta 1 into cos theta 2. This term into this term, that will be I square sin theta 1 into sin theta 2. Here I square is nothing but your minus 1. So this will be minus sin theta 1 into sin theta 2. So we can write this term minus this term, cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2, plus here I is the common for these two terms. So taken common I, we can write this one sin theta 1 cos theta 2 and this term cos theta 1 sin theta 2, right? Okay. Now this one cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2 is nothing but your cos theta 1 plus theta 2. So same thing it has been written. That implies this one, this term into this term will be equal to this one, this term cos theta 1 into cos theta 2 minus sin theta 1 into sin theta 2 is nothing but your cos theta 1 plus theta 2. That means cos A plus B. Here sin theta 1 into cos theta 2 plus sin theta 2 into cos theta 1 is nothing but your sin theta 1 plus sin theta 2. This is your equation number 1. Similarly, we can prove that cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 into cos theta 3 plus I sin theta 3 will be equal to cos theta 1 plus theta 2 plus theta 3 plus I sin theta 1 theta 2 plus theta 3. Likewise, also we can prove that cos theta 1 plus I sin theta 1 into cos theta 2 plus I sin theta 2 cos theta 3 plus I sin theta 3, so on cos theta n plus I sin theta n will be equal to cos theta 1 plus theta 2 plus theta 3, so on theta n plus I sin theta 1 plus theta 2 plus theta 3, so on plus theta n. Here you can write plus. Okay, this is your equation number 2. Now consider theta 1 equal to theta 2 equal to theta 3 up to theta n will be equal to theta. Hence equation number 2 will be how much? Here this one, same thing it has been written, left hand side I written as such, will be equal to this one theta 1 theta 2 theta 3 up to theta n. We have to write theta 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 up to n terms. I sin this theta 1 plus theta 2 plus theta 3 up to theta n can be written as theta plus theta up to nth term, right? So that implies here you can see these terms. See here also see if you are going to consider equation number 2, instead of theta 1 theta 2 theta 3 up to theta n, we have to substitute theta. So how many terms in the equation number 2, left hand side of equation number 2 are the n terms? So n term multiplication is nothing but cos theta plus I sin theta to the power n will be equal to, here you can see theta plus theta up to nth term means can be written as cos n theta plus I sin theta plus theta up to nth term will be n theta sin n theta. This we intend to prove. Here it has been proved. Cos theta, we want to prove that cos theta plus I sin theta to the power n will be equal to cos n theta plus I sin n theta. Here it has been proved. Okay. Now we are going to consider case 2 when n is a negative integer, right? So let us consider n equal to minus m, where m is the positive integer. M is the positive integer. Then cos theta plus I sin theta to the power n will be cos theta plus I sin theta to the power minus m. So here to the power minus m can be written as 1 by cos theta plus I sin theta to the power m, right? That implies this one, cos theta plus I sin theta to the power n will be equal to 1 by, here the denominator will be written as cos m theta plus I sin m theta by using case 1. When m is your positive integer, by considering case 1, we can write this one for this. Okay. Now we are going to multiply cos m theta minus I sin m theta with numerator and denominator. So numerator are written as such. Denominator will be cos square m theta plus sin square m theta. Here you can see a plus b, a minus b format is there. So a square means cos square m theta plus I sin m theta whole square. That means I square into sin square m theta. So minus I square itself minus 1 and minus will be there. So it will be plus sin square m theta, right? So that implies cos theta plus I sin theta to the power n will be equal to how much? Here you can see cos square m theta plus sin square m theta will be nothing but 1. Value will be 1. So we found cos m theta minus I sin m theta. Initially we have been considered that n equal to minus m. So obviously m will be equal to minus n. So here instead of m we can substitute minus n. Instead of m we can substitute minus n. But cos theta we know is a even function. So cos minus theta, here you can see this will be cos minus n theta. Cos minus n theta will be cos n theta because cos theta is your even function. But sin minus n theta will be minus sin n theta as sin theta is your odd function. So if it will be minus sin n theta, already minus is there, so plus I sin n theta. So it has been proved. Okay. Now we are going to go for if n is a fraction. So if n is a fraction, consider n will be equal to r by s. R is the positive or negative integer and s is the positive integer. Okay. So cos theta plus I sin theta can be written. How we are going to prove this one? Here you can see cos theta plus I sin theta will be equal to cos, this theta can be written as s into theta by s. S got cancelled, so cos theta as such it will be there, plus I sin s into theta by s, right? That implies cos theta plus I sin theta will be equal to, here you can see cos s, consider this one is your theta, sin s, this one will be theta. So this can be written as cos theta by s plus I sin theta by s to the power s by considering case 1. Here you can see that if we are going to consider, if we are going to consider the case 1, then case 1 tells that cos theta plus I sin theta to the power n will be equal to cos n theta plus I sin n theta. So if we have cos, suppose this one s theta plus I sin s theta, it can be written as cos theta plus I sin theta to the power s. Okay. Now take 𝒔 root both the side of this above equation, this side and this side, 𝒔 root. That means cos theta plus I sin theta to the power 1 by s will be equal to cos theta by s plus I sin theta by s. Here s is there, s into 1 by s. S has got cancelled, to the power 1. Got it? Okay. Now rth power of both the side. Now we are going to consider rth power of both the side for this equation. So this will be cos theta plus I sin theta to the power r by s will be equal to cos theta by s plus I sin theta by s to the power r. So same thing, it has been written cos theta plus I sin theta to the power r by s will be equal to cos theta by s plus I sin theta by s to the power r. That implies cos theta plus I sin theta to the power r by s will be equal to cos here by using Demoivre's theorem or case 1. Case 1 means r can be positive or negative. Already we have been considered initially that r may be positive or integer, positive or negative. So for positive or negative, already we have been proved in our case 2 and case 1. For case 2 we got this one, and case 1 also we got this one. Okay, so if it is so, then this will be cos r into, already theta by s is there, theta by s I sin r by s theta. Okay, by considering case 1 and case 2. So as we considered that n equal to r by s, instead of r by s we can substitute n. That implies cos theta plus I sin theta to the power n will be equal to here r by s. For r by s we can write n theta, and here r by s means sin n theta. Sin n theta. Okay, this one sin n theta has been proved. Okay, now the same Demoivre's theorem results for case 1, positive integer, negative integer and fraction, can be found by using Euler's formula. Here you can see, according to Euler's formula, we know that cos theta plus I sin theta is nothing but e to the I theta, right? Last class we have been discussed. Now consider case 1 when n is your positive integer. So cos theta plus I sin theta to the power n will be equal to e to the power I theta to the power n. So e to the power x to the power, suppose 2, we are going to consider this will be nothing but e to the power 2x. Same thing, it has been written that e to the power I n theta. So e to the power I n theta, if e to the I theta I am going to consider, then it will be cos theta plus I sin theta. Instead of a theta, if we are going to consider n theta, then we can write cos n theta plus I sin n theta, whatever we found in our case 1, considering as n is your positive integer. Consider n will be negative integer, that means here n will be considered as minus m. So cos theta plus I sin theta to the power n is nothing but cos theta plus I sin theta to the power minus m, as we considered n is equal to minus m. So cos theta plus I sin theta is nothing but e to the I theta by considering Euler's formula to the power minus m. So it will be e to the I minus m into theta. So if it is so, then by again considering Euler's formula like this one, so instead of theta we can write minus m theta. So cos minus m theta plus I sin minus m theta. Here cos theta is your even function, so cos minus m theta can be written as cos m theta minus sin m theta, because here sin is your odd function. So I sin minus m theta will be sin I sin m theta. Same result we have been already found here. Here you can see cos m theta minus sin m theta. Okay. Here if we are going to put instead of m equal to minus n, then we can found this one. Okay, this result. Now we are going to go for case 3 when n is a fraction. For that we consider n equal to r by s. So cos theta plus I sin theta to the power n can be written as cos theta plus I sin theta to the power r by s. So by Euler's formula, this can be written as e to the I theta to the power r by s. So e to the power I theta to the power r by s can be written as e to the I r by s theta. So again considering Euler's formula, we can write cos r by s theta plus I sin r by s theta. Already we consider r by s is your n, so cos n theta plus I sin n theta. So here by using Euler's formula, it is somewhat quite easy. So in your exam, by either way you can prove these 3 cases. By considering this case, by this way, by this procedure you can prove the Demoivre's theorem, or by this procedure, no issue. Okay, now now we are going to go for few numericals based on Demoivre's theorem and Euler's formula. Okay. The question number 18. See, in our last class up to question number 17 we have been discussed. Okay, so only for that this question numbered as question number 18. Express cos theta plus I sin theta to the power 4 by sin theta plus I cos theta to the power 5 in the form of x plus iy. Okay, x plus or minus iy. Okay, x plus iy, leave it. Okay, by using Demoivre's theorem, So in short, Demoivre's theorem I written DMT. Okay, so by DMT we know cos theta plus I sin theta to the power n equal to cos n theta plus I sin n theta. If n will be 4, then it will be cos 4 theta plus I sin 4 theta by DMT. Similarly, here you can see sin theta plus I cos theta to the power 5. Here DMT could not be applied directly because DMT is for cos theta plus I sin theta, but here sin theta plus I cos theta is there. So to apply DMT, we have to write this one in the form of this one. Okay, so for that, here I taken common from these two terms. So here to the power 5 means I to the power 5 taken common from these two terms. I means if I will become out from this bracket, it will be I to the power 5, and here sin theta to the sin theta by I plus cos theta. Got it? Here you can see, if I will take I common from these two terms, then here sin theta by I plus cos theta. But when I will be moved out from this bracket, here to the power 5 is there, so I to the power 5. Got it? Okay, so that implies sin theta plus I cos theta to the power 5 will be equal to, here I to the power 5 is nothing but your only I, because already we have been discussed in our first lecture that nth power of I will be how much. Here nth power of I, if I to the power 2n and n is your even, then it will be 1, and if n is odd, it will be -1. If here n is will be even, it will be I, n will be odd means minus I. So if I to the power 5 will be there, so it will be written as 2n plus 1, 2n plus 1 format. If I am going to write, then I to the power 2 into 2 plus 1. So 2 into 2 plus 1 is in the format of what? 2n plus 1. So this value either will be I or minus I. So this is the small n, and here the small n is your even, so the value will be I. So only for that, I to the power 5, I to the power 5 value is written as I, right? Okay, into sin theta by I plus cos theta to the power 5 is equal to I into, see, I will be moved to the numerator, it will be minus I. Always you have to remember, suppose 1 by I is there. If I will be moved to the numerator, it will be minus I. If I is there, if it will be moved towards to the denominator, then it will be minus I. You just remember, but actually how it is, here you can see 1 by I is there, so it can be written as I multiplied with the numerator, and denominator means I square it will be, so I square is your -1, so it will be minus I. Similarly, if I is there, I multiplied I with the numerator and denominator, so I square is -1, so 1 by -1 by I, right? So but you just remember in this way that if I will be moved to the numerator, it will be minus I, move to the denominator, it will be -1 by I. Okay, so it changed its position to numerator to denominator, or denominator to numerator means it will be minus. So here I move to numerator means it will be minus I sin theta plus cos theta to the power 5. Okay, that implies sin theta plus I cos theta to the power 5 will be equal to, here you can see this term written as the first term, cos theta minus I sin theta to the power 5. Now we are going to apply the DMT on this. So if I am going to apply the DMT, so it will be cos 5 theta minus I sin 5 theta. Okay, here I written by DMT. Now we are going to consider this term by this term. Already this term value I have been evaluated here, this one, and this term value sin theta plus I cos theta to the power 5, we found this one. Okay, we have to just substitute the cos theta plus I sin theta to the power 4 is nothing but cos 4 theta plus I sin 4 theta by this term I cos 5 theta minus I sin 5 theta, right? Okay, so here cos theta, this one again I am going to apply the DMT, the reverse DMT you can say. So it will be cos theta plus I sin theta to the power 4 divided by I is there I. So here reverse DMT if we are going to apply, then it will be cos theta minus I sin theta to the power 5, right? Now we are going to apply the Euler's formula for this one. Cos theta plus I sin theta is nothing but e to the right theta, already to the power 4 is there, 4. In the denominator you can see I, this one cos theta minus I sin theta will be written as e to the power minus I theta, already to the power 5 is there. Now here I is in the denominator. If I will move to the numerator, it will be minus I, and this is this e to the power I theta to the power 4 will be e to the power I 4 theta, and here this will be e to the power minus I 5 theta. If it will move to the numerator, it will be e to the power I 5 theta. So the power will be add up, so minus I e to the power I 9 theta, right? That implies this value will be equal to minus I. Here again I am going to apply the Euler's formula, cos 9 theta plus I sin 9 theta. Okay, minus I, if I am going to multiply with these two terms, then this will be minus I cos 9 theta here, and here minus I if I will multiply, then the value will be minus I square, minus here I square is nothing but minus 1, so it will be 1. That means sin 9 theta. So we got the answer is this one, right? So this is in the form of x plus iy. See, you can say that it is minus is there, so you can write in this format that sin 9 theta plus minus I cos 9 theta. Okay, this is not a issue, no problem itself. Okay, now we are going to go for another numerical, that is your. So before we are going to go for another numerical here, you can see the same question can be solved by using Euler's formula also. How? Cos theta plus I sin theta can be written as e to the I theta to the power 4. And here you can see, if I will take I common from these two terms, it will be I to the power 5. Here sin theta by I plus cos theta to the power 5. This will be e to the I 4 theta. And here I to the power 5 is nothing but I. And this one, if I will move to the numerator, it will be minus I sin theta plus cos theta to the power 5. And e to the power I 4 theta is there. I is there. Cos theta is written over here. Minus I sin theta to the power 5. So this one can be written as e to the power minus I theta to the power 5. Then this will be I, and this will be e to the power minus I 5 theta. So hence this I move to the numerator, it will be minus I e to the power, here you can see I 4 theta, it will move to the numerator, means e to the power I 5 theta. So hence it will be I e to the power I 9 theta. So this can be written as, by using Euler's formula, will be this one. When I minus I will multiply it with these two terms, we can get this one. Same thing. See, the same procedure here, I just reduce the steps. Okay. So you can solve this question by this way or this way. Okay. Now we are going to go for our next question. So before that, here I written a note that you have to remember always to solve the numericals. By Euler's formula, we know that e to the I theta is your cos theta plus I sin theta, e to the minus I theta is your cos theta minus I sin theta. Here e to the I theta plus e to the minus I theta by 2 is your cos theta. May you know these two equations, but you remember always. Okay, e to the I theta minus e to the minus I theta by 2i is your sin theta. Here you can see, you just add these two, cos theta plus I sin theta plus cos theta minus I sin theta. So plus minus got cancel. We found cos 2 cos theta by 2 is your cos theta. If I will subtract cos theta plus I sin theta minus this one, it will be minus cos theta plus I sin theta. So we can find 2i sin theta by 2i is nothing but your sin theta. Just remember these two expressions. Now question number 19. Find the value of sin pi by 7 plus I cos pi by 7 by sin pi by 7 minus I cos pi by 7 to the power 7. Okay. Actually, I left this question for you that you have to do by yourself, but here I am going to give you some hints that you can solve by yourself. So this can be written as sin pi by 7 plus I cos pi by 7 to the power 7 divided by sin pi by 7 minus I cos pi by 7 to the power 7. So I told that this type of question you can solve by this way or this way. So I suggest that by using Euler's formula, somewhat easy. Here we cannot apply directly the Euler's formula. If cos theta plus I sin theta format will be there, then we can apply. But here sin theta plus I cos theta format is there. So for that, to apply the Euler's formula, we have to modify these terms, okay, in the form of cos theta plus or minus I sin theta. So for that, I taken common from these two terms. So it will be I to the power 7 sin pi by 7 by I plus cos pi by 7 to the power 7 whole divided by, here also we have to do the same thing, that is your take common I to the 7 from these two terms. So if it will be moved outside of the bracket, then it will be I to the 7, and this will be sin pi by 7 by I minus cos pi by 7 to the power 7, right? So here I to the 7 got cancelled. Here if I will be moved to the numerator, it will be I sin pi by 7 plus cos pi by 7 to the power 7 divided by, here sorry, this will be minus I, here likewise minus I sin pi by 7 minus cos pi by 7 to the power 7, right? So this can be written as cos pi by 7 minus I sin pi by 7 to the power 7. Take minus common from these two terms, so it will be minus 1 to the power 7, and this will be cos pi by 7 plus I sin pi by 7 to the power 7. Okay, so now this can be written as in the form of e to the power theta format by using Euler's formula. That means this one cos theta minus I sin theta will be written as e to the minus I pi by 7 to the power 7 divided by I minus 1 to the power 7 is nothing but minus itself. So minus, this will be written as e to the power I pi by 7 to the power 7. So this will be minus 1, and numerator will be how much? E to the power, if I will multiply 7 with this one, e to the minus I pi divided by e to the I pi. Okay, so it will be minus 1 e to the minus I pi into e to the minus I pi, if this e to the I pi will be moved to the numerator, right? So here we can find minus 1 into e to the minus I 2 pi. So minus 1, so this will be, by using Euler's formula, it will be cos 2 pi minus I sin 2 pi. So cos 2 pi value is your 1, so sin 2 pi is your 0, so answer will be minus 1. Already I done all the steps, you just write down your note, right? Okay, now we are going to go for next question number 20. If x plus 1 by x equal to cos theta, then prove that x to the power n plus 1 by x to the power n equal to 2 cos n theta. So in the question it has been given that this one, x plus 1 by x equal to 2 cos theta. So you just add it, it will be x square plus 1 by x equal to 2 cos theta. So you just multiply x with this one and take this side, it will be x square minus 2x cos theta plus 1 equal to 0. This is a quadratic equation. The roots of this quadratic equation will be how much? X, the roots means here two roots, plus or minus, if I am going to consider the two roots. So the two roots or x will be equal to minus b means here already minus 2 cos theta is your b, so minus b means 2 cos theta plus or minus b square means minus 2 cos theta square, 4 cos square theta minus 4ac, 4 into a is your 1, c is also 1, root over by 2 into a is your 1, so by 2. So x equal to, we can found c 2 cos theta, here 4 taken outside of the root over means 2 cos square theta minus 1, 2 got cancelled. We found x equal to cos theta plus or minus root over of, taken minus common from these two terms, minus 1 minus cos square theta. 1 minus cos square theta is nothing but sin theta. Here minus root over of minus 1. Okay, minus means minus 1 is there. Root over of minus 1 is nothing but your I. So x equal to how much we found? Cos theta plus or minus I sin theta. Now x to the power n will be equal to to the power n cos theta plus I sin theta plus or minus I sin theta to the power n by using Demoivre's theorem. Here I have to write DMT. By using Demoivre's theorem, this will be cos n theta plus or minus I sin n theta, right? Likewise, x to the power minus n, if we are going to consider cos theta plus or minus I sin theta to the power minus n, it will be cos minus n theta plus or minus I sin minus n theta. So cos theta is your even function, so this value will be cos n theta. Here this value will be minus sin n theta. Here plus or minus, so it will be minus plus I sin theta. Got it? Okay. So now x to the power n, this value x to the power n plus, here x to the power minus n is nothing but 1 by x to the power n. So x to the power n plus 1 by x to the power n, if I am going to consider this value, x to the power n is nothing but this one, 1 by x to the power n is nothing but this one. Okay, x to the power n plus 1 by x to the power n value. So here you can see x to the power n plus 1 by x to the power n will be, here you can see cos n theta plus I sin n theta, here minus I sin n theta. If I am going to consider first two roots, here first root is your cos n theta plus I sin n theta. For this case, for this one, first root is your cos n theta minus I sin n theta. So minus I sin n theta, I theta plus I sin n theta will be got cancelled. We can find 2 cos n theta. If we are going to consider second root, for this case, second root is your cos n theta minus I sin n theta. For this one, cos n theta plus I sin n theta. So plus minus will be got cancelled. Also, we can find 2 cos n theta. Hence proved. Okay. X to the n plus 1 by this we intend to prove. No. So here we have been proved. Now we are going to go for the another question, that is your question number 21. Using Demoivre's theorem, derive the trigonometric identities. Cos 3 theta, these two things we have to prove. Cos 3 theta equal to cos q theta minus 3 cos theta into sin square theta. Sin 3 theta equal to 3 cos square theta into sin theta minus sin q theta. These are the two trigonometric identities, or you can say the formulas. Okay. So by DMT we know that cos theta plus I sin theta to the power n equal to cos n theta plus I sin n theta. N may be positive or negative or fraction, that we have been proved. Now we are going to consider n equal to 3. So it will be cos n 3 theta plus I sin 3 theta. So here left hand side cos theta plus I sin theta to the power 3 means a plus b whole q is there. So a q, that means cos q theta, plus b q, this one I sin theta whole q, that means I q sin q theta, plus 3 a square b. A means cos square, b means I sin theta. Okay, then 3a b square, 3a cos theta, b square means this one I sin theta square, will be equal to cos theta plus I sin theta. That means cos 3 theta plus I sin 3 theta. Same thing it has been written RHS. Okay, so here cos q theta. Here I to the power 3 is nothing but minus I sin q theta, plus here 3i cos square theta sin theta. Here I square will be there. Okay, I square is there, sin square theta also there. So I square is nothing but minus 1. So it will be minus 3 cos theta into sin square theta will be equal to cos 3 theta. Same thing it has been written RHS as such. Okay, so here real part we are going to separate, and imaginary part we are going to separately we have to write. Here cos q theta and this term, these two terms are the real part. Cos q theta minus 3 cos theta into sin square theta, plus here these two terms are imaginary parts. So I, if I'll take common from these two terms, I 3 cos square theta sin theta minus sin q theta, okay, will be equal to this one. Now if I'm going to equate the real and imaginary part of both the side of the equation, above equation, so this is your real part, this is your entire imaginary part. So this side, RHS side, cos 3 theta is your real part, and this is your imaginary part. So hence cos 3 theta will be equal to this one. Cos 3 theta will be equal to cos q theta minus 3 cos theta into sin square theta. Sin 3 theta will be equal to 3 cos square theta into sin theta minus sin q theta. What we intend to prove, it has been proved. Okay, it has been proved. Now we are going to go for another question, that is your question number 22. Find the value of a plus ib to the power n plus a minus ib to the power n in terms of r and theta. This is another type of question. So to solve this question, consider a equal to r cos theta, b equal to r sin theta. So a plus ib to the power n plus a minus ib to the power n will be equal to, instead of a we can write r cos theta, plus ib means instead of b we have to write r sin theta, I is there, to the power n, plus a minus ib will be written as r cos theta minus I r sin theta to the power n. Now we are going to use, see here r taken common from these two terms, means r to the power n will be, if r will be taken outside from this bracket, power is your n, so r to the power n cos theta plus I sin theta to the power n, plus here also r to the power n, if r will be taken outside, cos theta minus I sin theta to the power n, right? Now, so here I mistakenly written. So here, but if we are going to use the DMT for this case, if we are going to use the DMT, this will be cos n theta. Okay, just correct it. Cos n theta sin I sin n theta. Okay, and this will be cos n theta minus I sin n theta. So here plus I sin n theta minus I sin n theta will be got cancelled. We found 2r to the power n cos n theta. Cos n theta, I have to write once again. So this value will be 2r to the power n cos n theta. So finally we found the value of this one is your 2r to the power n cos n theta. If I have to put the whitener, because this note I have to upload for you that you can download, no? So here we found this value equal to 2r to the power n cos n theta. So here we have to stop our today's class. In our next class we are going to discuss roots of complex number by using DMT, Demoivre's theorem. First we are going to discuss cube roots of unit and some other numericals by using Demoivre's theorem. Okay, so thank you so much for watching this lecture. Thank you.